Hello and welcome to the Dark Reading News Desk from Black Hat USA 2025 at the Mandalay Bay in Las Vegas. We are happy to have you join us for an interesting conversation with Phillippe Laulheret.
Laulheret.
He is a senior vulnerability researcher at Cisco Talos, and he is here to tell us about his blockbuster new research, Revault, compromised by your secure SOC. Welcome, so happy to have you.
Thank you for having me.
Okay, this is a big deal. I mean, my colleagues and I were looking at the research that dropped yesterday, and we kept going, this is a really big, hairy deal. So the Revault flaw that you found is actually a flaw that affects firmware in millions of Dell laptops. Is that correct?
Yeah. So it's affecting this little board.
Okay. And what is this I'm looking at here?
So it's called like control vault. It's a control vault board, like our USH for the name as well. It's like Unified Secure Hub.
Okay.
And so you find that in like laptops from Dell that are like the Latitude and Precision models. So mostly the business ones.
Yeah.
And it connects inside the motherboard. You know, it's your laptop is built with it, and you're going to connect, like if you have a smart card reader, a fingerprint reader, or like an NFC card reader, you know, to log in into your machine and these kind of things. And that's the point of the board, is to like connect all of the things to the motherboard. And find like a couple of vulnerabilities in that chip.
Abnormalities. And so let's talk about what those are and what they mean.
Yeah. So something I found that was interesting is like any user on the machine can talk with the board and send comments to it, and all of that is like not documented. So it's like I had to like research that. And any user can send comments to the board, and if you're like a hacker,
I'm sorry to interrupt. You can send comments to the board. How do you do that?
So you have DLLs, so you have user APIs that you can call. So there's like some software. When you install the driver for Control Vault, it comes with a bunch of code. And the idea here is like a normal user doesn't know how to use it, but the system is meant to be used, you know, and so it comes with files that you can load and send, and they export commands that you can execute to communicate with the board.
And with that ability to communicate with the board, a malicious actor could do what?
Yeah. So if it's like a malicious user, like or user that's compromised, you can send kind of like malicious commands, or exploit bugs that are like running in the firmware of that chip that will corrupt memory inside, because that's running its own code, and you corrupt the memory, and basically you can get code execution on the chip, so you can run your own code. And from there, what I was able to do was retrieve secret keys that are stored in the chip. They're like unique to each device, so it's not everything is compromised, but that board could be, And from there, I was able to permanently change the firmware running on the chip. So you could reinstall Windows, it would still be modified.
I see.
And from there, if the board is compromised, you can send malicious command back to Windows, which would also compromise things running at the highest privilege on Windows. And that attack could also be kind of permanent, in the sense that if you reinstall Windows and that is malicious, it could, target Windows again. And also, I have a cute little demo where, because it's handling the fingerprint reader, you can also make it so that when any fingers touch the fingerprint reader, it's going to say, oh yes, that's totally the right user, and logs you in. So if you have set up your laptop to log in with fingerprint, that could also bypass the login screen.
So because this is a piece of equipment that's running without the average user even knowing about it, what drew you to research this and look into it?
Oh yeah, so I think it's mostly curiosity. So what happened was I wanted to find a new research project, and I was looking at I had a laptop, a Dell laptop, and I was looking what's running by it by default, as a normal user. And I spotted some services that were running with some security mitigation missing. So you have something called ASLR, which is address space layout randomization.
Okay.
And basically it's to make it exploitation harder. And it's pretty standard in the industry. You'd expect that on everything. But for that specific services that were meant to talk with the control vault board, that was missing. And so I was like, "Oh, that looks interesting. I should,
Juicy, yeah.
It's like, oh, I want to investigate more." And I started looking at the files, like the install files for Control Vault, and see what's the whole thing. And I also noticed that it would come with its own firmware file, so specifically like the code that's meant to run on the chip. And some like half of it was in plain text or clear text, so I could just load it into my reversing tools. But part of it was encrypted, and that's like the main thing was encrypted. And so I was like, "Ooh, I really want to decrypt it to see what's in there." It's like curiosity, and I managed to do it. And that's where I started like looking for vulnerabilities in the main stuff that I decrypted, and I started finding potential bugs, and I followed that thread until like what I just like the
So
full attack.
this revault of vulnerabilities, there's actually two separate CVEs. Is that correct?
Oh, this is like five.
Five
CVs.
CVEs.
Yeah.
Oh, okay. And but they are all generally part of this
Yes,
firmware vulnerability.
So it's kind of like we reported multiple vulnerabilities,
Okay.
and I tied the three together to achieve what I described.
Okay.
So there are like two. One was like a kind of a memory corruption in the firmware, and one was a Stack Overflow in a different function. And I combined the two in order to exploit the one function on the firmware to get code execution. And then there was like a third one that was more on the host side, so on the Windows. And I was able to use the first two to corrupt the board, and then use the third one to get back to Windows.
At what point did you realize you had something very big on your hands? At what point did you realize this was potentially going to affect millions of laptops, largely in businesses and government? I mean, what was that moment like?
So it's funny because I was excited by the work. So I was more like, I had this plan. It's like, oh, it would be nice if I could do this and then that and then that. And the whole thing, started unfolding. And the actual consequence of, oh yeah, it's going to be found in a lot of places, come really late in the process. And I was like, that is exciting, but that's also, it's an exciting challenge to have,
So why did you call it Revault? Tell me a little bit about what the naming was like.
Yeah, okay. So that one was just my inspiration when I was, trying to like submit to conferences. But in my head, like the system is called Control Vault.
Right.
And because it hacks back your machine, I was like, it's a little like if it's Revolt, like a, and that's why I came up with the name. But there was like very little brainstorming about it.
Okay, it's fair enough. Well, it's catchy.
Yeah.
I have it.
Thank you.
Remember, yeah. And so now I think it's important for us to talk about beyond your findings. These firmware vulnerabilities are hiding in plain sight right now, and this is sort of an unaddressed area of security. Would you say the firmware vulnerability?
I would say it's something it's good to investigate.
Okay.
Because there is a lot of complexity in all of those. So many firmwares, and those blobs are usually like undocumented and oftentimes encrypted. So it's hard to know really what's going on. And so whether or not there are like vulnerabilities, it's hard to say because you have to look into it, and it requires a lot of work before that. But I think it's firmware security is something that has been going on for a while, and it's keep going on. And I feel like for Control Vault, I think is like I wasn't aware of it, and it's like not the most obvious target. In the past, like a couple of years ago, like Wi-Fi vulnerabilities was a big thing. Where like the same like the Wi-Fi board is also like a embedded system that runs its own code, and it's also really hard to look at. But I guess like people, targeted that quite a bit, and so now maybe it's less easy to find vulnerabilities in that. Control Vault, I was lucky to maybe be one of the first person to look at it. But yeah, I think it's interesting for like anyone that cares about threat models and whatnot to consider like what are the components in the system that have like undocumented blobs of firmware and so on.
So let's talk a little bit about this. Has been patched, and you went to Dell with this, and what did they say to you?
Oh yeah, so I think they're like really receptive. We sent the thing, so they worked with so Dell is the manufacturer and it's made for Dell, but the chip is Broadcom and the firmware is written by Broadcom. So there's like a bit of a, I think from a operation perspective, it's a little challenging, because you have like multiple actors, and I think the Broadcom was quick into their like patches, and then Dell was also successful into sharing that with their customers, and everything was
But they were receptive and,
Yeah, yeah, yeah.
and got it patched quickly. So anyone now who's running these Dell laptops can feel confident that these vulnerabilities have been patched.
Yeah, the vulnerabilities we're talking about today were patched, and Windows. So the laptop can update automatically. I believe there is like some Dell software that automatically install updates, but for Control Vault for Control Vault, it also gets pushed by Windows Update.
Okay.
So by doing nothing, the patch is. From what I've seen,
Right.
it's pushed automatically. Like my laptop got fixed, and I was like, okay, that's good,
Look at
So yeah, and I have like a demo laptop where like I do all of my recording, and this one has been like on airplane mode for like months now because it's like I don't want it to get fixed.
Right, right. Well, congratulations. This is
Thank
a
you.
huge find, and thank you so much for joining us at the Dark Reading News Desk. It's been a
Yeah.
delight.
Thank you for having me. This
Of
was great.
course, of course. Thank you so much for watching. This has been Phillippe Laulheret from Cisco Talos at the Dark Reading News Desk from Black Hat USA 2025.